So in this question 1a, we're supposed to find the values of t in this function here. That'll give us 0 for f of t. So let's try this. Let's set f of t, which is this one right here, t squared minus 1, t squared plus 1. Let's set it equal to 0. Right? So right here, there's the f of t, there's the equal sign, and there's the 0. So by the zero factor property, t squared minus 1 could be 0, or t squared plus 1 could be 0. And on the left side here, we're going to factor. So out of here, let's set that equal to 0. We'll get t and t, difference of two squares, right? So we'll get plus 1 and minus 1, from which we can see we'll get t equals negative 1 and plus 1. And from this one, we're going to get t squared equals negative 1. So these are imaginary, and we're just supposed to find the real numbers that are going to give us 0 for f of t. So our conclusion now is just that we're going to get t equals negative 1 and positive 1. So we will claim now that that is our answer to part A. And here in part B, we're asked to find the values of t for which the derivative is 0. Now remember, the derivative is the slope of the tangent line, so we need to differentiate this function over here. So let's do it. Now we could multiply these together, or we could use the product rule, and since we're kind of in the product rule section, let's go ahead and use the product rule for this. So the product rule says this, that the derivative f prime is, all right, I'm going to write it this way. It's the first. I'm going to get rid of that. I don't like to write this first here. Let me just simplify this notation. So what we're going to have here is this. We're going to have that the derivative is the derivative of the first times the second factor plus the first factor times the derivative of the second factor. So let's do that here. So we're going to get f prime of t is equal to, now, the derivative of the first factor. Here's the first factor. This derivative here is 2t. And we get a 0 because the derivative of a constant is 0, so we're going to get 2t. There's the derivative of the first times the second, t squared plus 1. And then plus, right, here's our plus right here. The first factor, now the first factor here is t squared minus 1. So we'll get t squared minus 1 times the derivative of the second. Okay, now the second, bring it over here. Here's the second factor. This derivative is 2t, and then a 0 here, right, because that's a constant. Derivative of a constant is 0. So we're just going to get a 2t here. So here's the calculus part. There's our derivatives. Let's clean it up with some algebra. We'll multiply through. So we will get that f prime of t is, okay, let's multiply through here. So we'll get 2t cubed plus 2t. And then over here, we'll get plus 2t cubed minus 2t. So it looks like these two t's here, and those are going to cancel each other out. So we will get f prime of t equals, okay, 2t cubed and another 2t cubed is 4t cubed. And we want to know what's going to make this thing 0. What t values are going to produce 0? So we're looking for this. We're looking for f prime of t equaling 0. So f prime, well, here's f prime right here. So we're going to get 4t cubed equals 0. And the only way this can happen is for t to be 0, right? You're multiplying numbers together, 4 and t cubed, and you're getting 0. One of them has to be 0, and it's not the 4. So the only way it can happen is for t to be 0. So we're going to claim now that the derivative is 0 when t equals 0. And what that means is that if we were to graph this function at t equals 0, we would have a horizontal tangent line.